So far, you have learned how to calculate the amount of moles of reactants or products given amount of moles. In stoichiometry, we call those problems mole-to-mole problems. I was teaching also how to calculate the amount in grams, okay, given the amount of mole of reactants or products. If we call, one more time, in stoichiometry, a mole to grams problem. What happens when you have a mole to gram problem? That you have to use an extra conversion factor. And what is that extra conversion factor? The molar mass, because that's the only conversion factor that is relating amount of moles with mass in there. Okay, mole to mole stoichiometry problems, they are simple because you don't need an extra conversion factor. Mole to mass, you need an extra one, which is the molar mass, but you're going to do that at the end because they are looking for the answer in grams. But now we have another type of stoichiometry problem, and this is mass to mass. As you can see, instead of giving you the amount of moles that are involved in the reaction, the problem is gonna give you the mass. Now, remember that in stoichiometry we are using mole ratios as conversion factors. So if the amount, the given amount, okay, the information that you get from the problem is in grams, can you use the mole ratios as conversion factor? The answer is no. So what do you need to do? Okay, what is elemental? Okay, you need to convert those grams into moles in order to use the mole ratio. How are you going to do that? Molar mass. You have an example here in front of you. This is a decomposition chemical reaction. Decomposition chemical reaction. You have sodium nitride, better known as sodium azide, and they are putting, this is an ionic compound, a solid that is placed inside the bags of the automobiles. When they are exposed to a certain force, what's going to happen? That salt is going to decompose into another solid that is going to stay there, plus a gas. The gas is the one that is going to expand. The gas is the one that is going to inflate the bags in there. Okay? Now, it's decomposing into sodium and nitrogen. And you have over here, see, the balanced chemical equation. See, meaning that you don't have to worry about that. If you know that from the balanced chemical equation, the only thing, the information that you can get from there is the mole ratios, okay? Now, they want to find the amount of nitrogen that is going to be produced, mass of nitrogen, so in grams, that is going to be produced when 100 grams of sodium nitrate are placed inside the bag, okay? And you have that over there. Once that you have your balanced chemical equation, okay, you don't have to write all mole ratios. So over here, as you can see, I was writing the one that I'm going to use. Because if sodium nitrate was given and I need to find the amount of nitrogen, I'm not going to write this mole ratio involving these two substance because I don't need that. So I was writing the relationship between the two that I need. As you can see, mole ratios, one more time, involving moles, because that is the information that you get from the balanced chemical equation. Now, do you have the moles of sodium nitrate? No, they're giving you the mass. See that? The mass. How can you convert that into moles, molar mass? And that's why over here, okay, I was looking for the molar mass of sodium nitrate. Molar mass, because the amount that I have or the amount that is given is expressed in grams. If I have that in grams, there's no way that I can use my mole ratio as a conversion factor. So I need a molar mass because I will have to convert that into moles first. Now, the problem wants the final answer also in grams. That's why over here, next to the molar mass of sodium nitrate, I was calculating the molar mass of this diatomic molecule. You just keep that in mind. Since it's a diatomic molecule, you have to multiply the atomic mass expressed in grams by 2, okay, to get the grams that you're going to find in a mole of this diatomic molecule. Once that you have the molar mass of both of them, okay, you're going to proceed. You know that's the next step. You're going to proceed to set up your problem. Okay, let me put this over here so you can see that better. Always, you're going to start with what you have. What do you have? Grams of sodium nitrite. Okay, so can you use your conversion factor if you have grams? No, so you have to convert that into moles. So I'm going to multiply by my conversion factor. Remember that you're always multiplying. The problem is setting that up. Okay, so if you have grams and you want to get rid of the grams, what are you going to put the grams of sodium nitrate? Of course that you have to put that in the denominator. So your first conversion factor over here, molar mass, the mass of sodium nitrate that you're going to find in 1 mole. When you cancel grams of sodium nitrate, you are left with mole of sodium nitrate. That's what you want. You don't want that. You don't want that. You're looking for amount of nitrogen. Now I'm going to use another conversion factor that is related. Mole of sodium nitrate with the mole of nitrogen gas. See that? And this conversion factor, the one in blue, I was getting that conversion factor from my balanced chemical equation. See? That one over here. See? But when I cancel mole of sodium nitrite with mole of sodium nitrite, I am left with moles of nitrogen. The problem is asking for that. Moles of nitrogen gas. The problem is not asking for that. So you have to convert those moles of nitrogen into grams. How are you going to do that? Molar mass. You have to set that up properly. See? It's a big chorizo. Yeah, I know that you don't like big chorizo, but you can do that by steps if you want to. I was doing that in one step because you were doing conversions like this the chapter before. So you're familiar with big chorizos. Okay, how are you going to solve this? And you have the arrows in there that are indicating the operation. So you multiply numerators times numerators, denominators times denominators. Remember that when you have over here a whole number or whatever number, it doesn't matter, you have a decimal, you can put that over 1 so you don't get confused. And then you're going to solve this big expression the same way that you solve a multiplication of fraction. Numerators times numerators, denominators times denominators, and then you divide. It is gonna give you the amount in grams of nitrogen gas that was produced. Careful in the final answer because over here I think that the problem, let me go up. Problem, okay, see, you have here 4 significant figures. Okay, so the final answer, that's the only number that is given. So the final answer has to be expressed with 4 significant figures. So you have to round until you have 4 significant figures there in your answer, and then you write the final answer using complete sentence. So the amount of nitrogen produced after the decomposition, the decomposition of 100 grams of that ionic compound, 64.64 grams. Okay.